In this tutorial video we will be learning about Bernstein Vazirani algorithm. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of Blueqat. We can do it by using this code !pip install Blueqat. Type the code that was shown earlier in Google Colab. Then click on play button and Blueqat will be installed. Bernstein Vazirani algorithm overview. In this algorithm, we consider the following function that takes x as input and computes the output using the internal bit sequence A. The goal is to find the bit sequence A from the output of f of A, x. A, x are n-bit strings A equals A0 A1 till A, n-1, x equals x0 x1 till x, n-1, respectively. Consider the case where A is a 4-bit sequence 1001. A foolproof way to find x in classical calculations is to input x in order, with only one bit set to 1 and the others to 0, as in x equals 1000, 100, 10, 1. From 0.0 equals 0.1 equals 0, the bit with xi equals 0, do not affect the result, so we can determine the value of ai one bit at a time. Calculate f of x where a equals 1001 for 4 different x as follows. 1001.1000, mod 2 equals 1, 1001.0100, mod 2 equals 0, 1001.0010, mod 2 equals 0, 1001.0001, mod 2 equals 1. From the above output, we can get a equals 1001. The Bernstein Vazirani algorithm uses quantum superposition to find A in a single calculation. The specific circuit for the case A equals 1001 is as follows. Let the CX gate act on the qubits I, where AI equals 1 are the control qubits, respectively. All target qubits are the 4th auxiliary qubit. Let's check the states of Psi1. Next, check the state of Psi2. Let's focus only on the 0th and 4th qubits that the CX gates act on. By acting on the 0th and 4th qubits with a CX gate, we inverted the phase of the 0th qubit, changing it to plus to minus. Similarly, with CX gates acting on the 3rd and 4th qubits, the state Psi3 is as follows. Finally, let the H gate act. Measure the 0th to 3rd qubits and we get 1001 as the measurement result. Now we can find A. Let's implement this with Blueqat. Copy the code and click on the play button to import circuit and numpy. Now copy the code to prepare a function to act Oracle UF. The following is the main body of the algorithm. First, determine the A you want to find by a random number. Find A from the output result of the quantum circuit using the oracle, and check if the answer is correct. From the above, we were able to find the A that the oracle has internally by using the Bernstein Vazirani algorithm. That's all for today. Thank you.